This is Algebra 2, Unit 11, Lesson 8, the rest of the notes on the frequency and period of a sinusoidal graph. Okay, so let's see if we can graph the function y equals 2 sine 4x on the grid below for one full period to the left and right of the y-axis, and label the scale in your axes. So what we're going to do is we are going to graph this sine function so that it's one full period, which means it's going to look like this, one full period on each side of the graph, to the left and right, by figuring out what the scale is going to be. All right, so we want to do one complete revolution, which is a period, using y equals 2 sine 4x. So let's look at what we know for sure. All right, so we have y equals 2 sine 4x. All right, so A, we know, is the amplitude. Which value is the amplitude on this? A would be 2. So that means when we do this graph, instead of going 0, 1, 0, negative 1, 0, it's going to go 0, 2, 0, negative 2, 0, because the amplitude is 2. The height of the wave is actually going to be 2. All right, the next thing that we need to figure out is the frequency. All right, what is the frequency on this? It would be the B value. The B value is actually going to be 4. All right, so what we need to figure out is if it's the B value is 4, what period is going to have this frequency of 4? All right, so that means within 2 pi, we are actually going to have 4 complete revolutions. All right, now what we're going to do is we're going to do one complete revolution, so we need to figure out how long it would take to get one complete revolution. All right, now remember we have a formula, B times P is equal to 2 pi. All right, so if I have 4 in 2 pi, and I divide it out, divide by 4, that means P is going to be pi over 2, or 1/2 pi. All right, so that means if I want to do one full cycle of sine, it's going to happen within pi over 2. So if I do one full cycle here, that means pi over 2 is going to be here, and negative pi over 2 will be down here. Okay, so if I want to do one full cycle. So what does that mean for each of these sections? Well, that means each section is going to be divided into 4, because remember, this is quadrantal angles. You're going to do each quadrant. So if I take pi over 2 divided by 4, that gives me pi over 2 times a fourth, which is pi over 8. That means each of these sections is going to be pi over 8. So this is pi over 8. This would be 2 pi over 8, which would be pi over 4. And then this would be 3 pi over 8. And then it would be 4 pi over 8, which would be pi over 2. And in reverse, this would be negative pi over 8, negative pi over 4, and negative 3 pi over 8. So when you figure out what the period is, if you divide it by 4, that'll give you what it is each quadrant. All right, so now if I graph this, remember for sine, you start at the midline. In this case, the midline is going to be 0. The amplitude we said was 2, so at the first quadrant, it's going to go to 2, back to 0, down to negative 2, and then back to 0. So one full scale of this looks like that. And if I just do it in reverse, it would be going back like this. All right, now, just to show you that this is correct, if I set this on the graph on my calculator, just to show you, y equals 2 sine 4x. All right, and if I set this window, my window is, this is from negative 2 pi to 2 pi. If I graph this, you can see within that I have 1, 2, 3, 4 complete revolutions of sine within 2 pi. Now, if I fix my window with the same one that I have here, all right, we're going from negative pi over 2 divided by 2 to pi over 2. And my scale for this one, each quadrant is going to be at pi over 8. So pi divided by 8. And I think my with this is to match what's on the paper, it'd be -4 to +4. All right, and if I graph this, you can see this matches exactly what we just did. So what I did was that I changed the quadrants on this, the period on this, to show that instead of having one full revolution over this, I can set it so it's what I need. Okay, so you can see how we did that. So what we need to do is figure out the amplitude, figure out the frequency, use the frequency to find the period. Remember, the period is how long it takes to go one full cycle of sine or cosine. All right, let's do the last one. All right, let's look at exercise 6. The heights of the tides can be described using a sinusoidal model of the form y equals a cosine bx plus c. If high tides are separated by 24 hours, which of the following gives the frequency b of the curve? Okay, now what we have is a unit of time here. We have a unit of time of 24 hours. High tides are separated by 24 hours. All right, so that means for cosine, it starts at high tide, and then it goes and it comes back up. So if you are going from here, high tide to high tide, isn't that the period of the graph? So if the period is going to be 24 hours. All right, so to figure out the frequency, remember we know b times p is equal to 2 pi. So your frequency is going to be b, your period is 24, so it's b times 24 equals 2 pi. So if we solve this for b, divide by 24, so b is going to equal 2 over 24 reduces to pi over 12. So that means it's going to be answer number 3. Okay, so that is frequency and period of a sinusoidal graph.